Dear students, good morning to everyone. Today we are going to discuss about the seventh part of electrostatics. Already we have discussed six parts. Up to the sixth part we have discussed about electric field due to point charge, electric field due to an electric dipole on its axial line and also equatorial line. Based on that important points we have discussed in the previous video. In this video we are going to discuss about torque experienced by the electric dipole and electric potential energy and electric potential due to a point charge. These are the topics we are going to discuss. Okay, right. Now let us move to the first topic. Torque experienced by the electric dipole in a uniform electric field. Okay, already we have discussed if any point charge is placed in the uniform electric field of induction, it will experience a force that is given by Q into E. In the previous topic we have discussed that is nothing but Q naught into E. What is Q naught? Q naught is nothing but a charge, test charge. Okay, and E is nothing but electric field. Instead of point charge, here we are considering the electric dipole. Okay, so in this electric dipole I have drawn in this diagram, one is plus Q and another one is minus Q. What is the dipole distance between them? That is equal to what? 2a. Suppose if we consider the midpoint, let me take here, so this part is A, this part is A. So total distance, length of the dipole, otherwise dipole distance is equal to what? 2a. It is given the first point. And our midpoint is nothing but the middle point. Okay. From the middle point we can consider what is the force experienced by the positive charge and the negative charge. The third point I have given, that is nothing but O be the midpoint and dipole is placed in the uniform electric field. In the uniform electric field we are placing the electric dipole. What will be there? Dipole is nothing but it consisting of two equal and opposite charges, right? Yes. So due to the positive charge, what is the force experienced? That is known as QE. Then what is the direction of force experience? It is always acts along the direction of electric field, that is mentioned, highlighted here. Okay, right. Then what about the negative charge? If minus Q is also placed in the same uniform electric field, what is the magnitude of the force that is given by minus QE, and what is the direction of force experienced due to the negative charge? That is nothing but just opposite to the electric field, because the electric field is acting along this direction, the force due to the negative charge is just acting opposite direction. That's why I wrote here minus Q in the opposite direction of electric field. Okay, right. We know that in the uniform electric field, the total force acting due to the electric dipole, it is always equal to 0. Okay, so this is the important point we have to remember. The total force or the net force or the resulting force of a dipole kept in the uniform electric field is always equal to 0. But then next one is, if the two forces acting at different points, it will not experience a force. Instead of force, it will constitute a couple. That couple is known as in the electrostatics, that is nothing but torque. If it experiences a torque, what is the magnitude of the torque? How can we calculate the torque experienced by the electric dipole kept in the uniform electric field of induction, capital E? Okay, right. In this step, the total torque on the dipole about the point O is given by tau is equal to, this tau is nothing but torque. Okay, torque is represented by the symbol tau. How we have to pronounce it? TAU, tau. Okay, right. So tau is equal to OA vector into minus QE plus OB vector into plus QE. Okay, so OA is nothing but what? distance from the midpoint. OB is nothing but distance from the midpoint. They are represented by small a. What is plus QE and minus QE? They are the forces exerted by both the positive and negative charges. Okay, when we comparing these two, we can understand that the magnitude of the force experienced by both the positive and negative charge is same, but the direction is different. That's why we are representing here minus QE and plus QE. Okay, then how can we calculate the torque experienced, total torque experienced? It can be calculated by using the right hand corkscrew rule. The torque is perpendicular to the plane. It is one more question may be expected. Okay, right. How can we calculate the magnitude of the dipole? Now we can calculate here. Tau vector is equal to, here we are going to calculate the tau. To find out the tau, we have to calculate the magnitude of the force and its perpendicular distance. Okay, right. So magnitude of the force is nothing but magnitude of, or modulus of, minus QE. OA vector is nothing but what? Distance between O and A. So it is also just a scalar quantity, so we are taking the magnitude. Then due to the positive charge, the magnitude of the force is given by modulus of plus QE, and the distance between O and B is nothing but what? A. It is given by modulus of OB. Okay, then what is sin theta, sir? Sin theta is nothing but it is the angle made by E and P. It is the angle made by E and P. That is known as sin theta here. Okay, so tau is equal to, now we are going to substitute the value. So OA is equal to what? Small a. What is QE? Modulus of minus QE, that is QE. Sin theta, it will come directly. Okay, right. Then OB is equal to what? Small a. Modulus of QE, that is nothing but QE. Sin theta, it will come directly. Okay, now if we look at this equation, what is the general term? We can calculate. Okay, Q is common in both. Okay, so that we are taking QE is common, and what will be the remaining? 2a sin theta. Okay, then we know that the dipole moment is the dipole moment of any dipole is given by, it is equal to product of any one of the charge into dipole distance, that is given by Q into 2a. That's why I encircled here Q and 2a, that is equal to what? P, dipole moment, and E will be there. So tau is equal to P sin theta. Okay, right. Then one more thing you have to understand, if they are asking about the magnitude of the tau, we have to write like this: tau is equal to P sin theta. Okay, suppose if they are asking the vector form, we have to write tau vector is equal to P vector cross E vector. This is the vector form of torque experienced by the electric dipole in the uniform electric field. Okay, right. Then already I explained you, theta is nothing but sine of the angle between electric dipole moment and electric field. Okay, this is also already we have discussed, where P is equal to Q into 2a. Then what are the important points we have to remember in this concept of torque experienced? The first point, it is given by the magnitude of torque, it will be maximum when the dipole is normal or perpendicular to the direction of electric field. Then we can write, already we know the formula for magnitude. What is the formula for magnitude? Tau is equal to what? P E sin theta. Okay, so perpendicular means normal. Normal means theta is equal to 90 degree. So we can substitute the theta value in this equation. Then we will get tau is equal to P E sin 90. Sin 90 is equal to what? 1. Then we can write tau is equal to P E. Okay. Then what is the direction of torque? Torque, it is always tends to set the dipole along the direction of electric field. So this is the important one more point. Okay, right. Suppose If the dipole is aligned the direction of electric field. So aligned means coincide. So theta value is equal to what? 0. Sin 0 is equal to what? 0. So that tau is equal to p sin theta. It is the general formula for magnitude. Okay, so sin 0 is equal to 0 means the total term it will be 0. Pe into 0, anything into 0 is equal to what? 0. So that torque value it will be equal to 0 if it is aligned with the electric field. Okay, suppose if the electric dipole is placed in non-uniform electric field, what will happen? If it is a uniform electric field, the net force acting on it is equal to 0. So what will happen? It will result in a torque. Torque value is given by tau is equal to P E sin theta. In vector form, how can we write? Tau vector is equal to P cross E. Okay, right. Then the torque value it will be maximum if the electric dipole is oriented normal to the direction of electric field or perpendicular to the direction of electric field. Torque value will be maximum. If the dipole is placed or aligned along the direction of aligned with the direction of electric field, theta value is equal to 0, sin 0 is equal to 0, so tau is equal to 0. Suppose if the electric dipole is placed in the non-uniform electric field, then what will happen? If it is kept in the non-uniform electric field, then the force experienced by the plus charge and minus charge, positive and negative charge, it will be different. Okay, in this point, in this word, you have to concentrate. How can we understand this? In a non-uniform electric field, the magnitude of force exerted by the both positive and negative charge are different. Different means they are different in magnitude also. This is very important because already we have discussed in the uniform electric field, since both the point charges are experienced same magnitude of force and acting different direction, they are constitute the electric dipole or constitute a couple or the torque. But in this non-uniform electric field, there is no assurance for the force experienced by both the charges are unity. Both the point charges are same. Okay, their magnitude is also different, so that in this case, along with the torque, the additional force is also experienced. So what is the thing we have to understand here? When it is kept in the non-uniform electric field, not only the torque but also the force is also experienced. If it is kept in the uniform electric field, only torque it will be experienced. Why I stressed again and again in this point means one more question may be asked. If the electric dipole is kept in the presence of uniform electric field, the following will experience. They will give only torque, they will give only force. Then third option, both the force and torque. Then fourth option, last option, they will give neither force nor torque. So in this case, such a type of question if they will ask, we have to answer clearly. If you know this concept, if you know or if you understand this concept clearly, definitely you can answer for that question. Uniform electric field, only torque. Non-uniform electric field, both the torque and the force. Okay, so these are the important thing we have to understand while preparing the torque experienced by the electric dipole in the uniform electric field of intensity E. Okay, are you clear? So definitely we can expect the question in 5 mark question or in a 3 mark question, and also 1 mark question we can expect from this. Okay, right. Next we can discuss about electrostatic potential energy. So electrostatic potential energy, how it will be produced, we can discuss the next topic. Okay, right.